this first example with you, and then you can try part B. And then in example 2, maybe I could do part A and you could try part B. So it says find S sub n for this arithmetic series. So let's think about, if we want to use the formula, what do we need to know? We would need the number of terms, we would need a sub 1, and we would need a sub n. So we need to know those 3 pieces of information, because the formula is n divided by 2, number of pairs, times a sub 1 plus a sub n, basically your first term plus your last term. So if I'm going to use the formula, I need those 3 pieces of information. If I want to use sigma notation, I do need to know the number of terms, right? Because it goes from, term what to term what. And then I need to know the formula. So the formula, I need to know the difference, right? And then the first term and the last term. So based on what information they give you, you may prefer one strategy over the other. What did they tell me? They told me the first term. Oh, they told me the last term, and they told me the number of terms. So this is directly set up for you to use the formula. Sigma notation will actually be more challenging because we have to figure out the common difference. So using the formula, if I'm going from term 1 to term n, they're telling me n is 14. So that tells me how many terms there are, right? So how many pairs will there be? There's going to be 7 pairs, because that's 14 divided by 2. And then all I have to do is take a sub 1, which is 25, and add a sub 14, which is 259, and that will give me my total. So they gave me all 3 pieces of information that I needed. So I can do 7 times 25 plus 259 on my calculator. So someone type it in and tell me what you got. Does anyone need a calculator? You need one? 1988. Let's see if we can set it up to practice that hard. I could say n goes from 1 to 14, right? The first term to the 14th term. But I have to write the formula for this arithmetic sequence. So I know that I start at 25, but I'm not sure how much I add each time. So how can I find the common difference? I know the total went from 25 to 259, so can't I find the difference between the total and divide by 14 terms? So let's see, I would take 259 minus 25, so that's a total of 234 divided by 14. Uh-oh, is that right? I don't want to divide by 14, I want to divide by 13, right? Because from the first term, wouldn't you only add the difference 13 times to get to the 14th term? It comes out, does it come out as an integer? 234, whoops, divided by 13 is 18. So my common difference is 18. So I'm adding 18n minus 1 times. So just, we want to get really familiar with how to do it both ways. So see if when you type that into your calculator, it should also come out to 1988. On a quiz, I'm not going to make you do it both ways, but you want to be really comfortable with these formulas and how to do it multiple ways. So n goes from 1 to 14, 25 plus 18 times n minus 1. So we should just confirm that, yes, it did come out to 1988. Does anyone need me to look at their calculator because it didn't come out correctly? It's probably a parentheses or a minus sign as a multiplication negative sign or something. You all got it? 1988? All right, why don't you try the next one? Try 1B for a minute. See if you can figure out the difference. See if you can do it using the formula and sigma notation. If you want to take a stab at example 2, go for it, but I'll do 2A formula. Do you see how those are set up directly to do the formula really quick and easy? So I think you'll be able to recognize, to do this, I don't know my common difference. Oh, but I know everything I need to do the formula. So it's nice to have more than one way to do a problem. When we get to the bottom two, now the sigma notation is easier and it actually makes more work to do the formula. So it's nice to have the two different avenues. Did you get for number 2 the common difference was 0.57? Okay, so let's take a look at the strategy that you would need for example 2, and then you can try 2b. All right, so I know the number of terms is 50, right? So I'm good with pairs. I know my pairs would be 25. For people who weren't here, it also works for odd numbers. So if you had 15 numbers, you had 7.5 pairs. It's okay to have a decimal number of pairs. It'll still work. So you just divide your terms by 2, and then I know my first term is 29, but I do not know the last term of the sequence. So to figure out the last term of the sequence, we're going to need the formula for this sequence, right? For an arithmetic, you take the first term and you add your common difference n minus 1 times. I just have to find my common difference. Is that 15? 44 minus 29 is 15. And now I'm going to generate the 50th term by plugging in 50. So that will give me my last term of this sequence. So I'm going to do 29 plus 15 times 49. So 764 would be the last term of this 50-term sequence. And then this one is actually set up for you to do sigma notation really quick and easy, because you know that it goes from 1 to 50, and we just wrote our sequence out, right? So this is our sequence, 29 plus 15 n minus 1. So when you type both of these into your calculator, we should hopefully get the same answer. So try typing them in and see if you try example 2b. I'll put up 2b in just a minute or two, but try the examples on the back. The examples on the back are all applications that are word problems dealing with either a sequence or a series. So see if you can use your knowledge. I think that some of them are like the number of bricks or logs or adding money to a piggy bank. So ways. I made the mistake of subtracting 6, but you're adding 6, right? Because you're getting less negative every time. So 10,521 for both ways. All right, so take a step. The application problems are not super, super challenging. They're more just kind of adding together some basic patterns. They will get more challenging for geometric, but arithmetic to me is kind of basic word problems, but you have to know if you're doing a series or a sequence. And in example 3, it's a 2-part answer. How many bricks in the 50th step? That's a sequence. But how many bricks are in the whole staircase? That's a series, right? You might want to know how many bricks do I need for this wall or this staircase. Or in an auditorium, usually there's fewer seats in the front, but as you go backwards, it gets wider and wider in an arc, right? So how many seats are in this auditorium? 5. So this is the answer to 3, 4, and 5. And now you can go to the next page and try the page 509 guided practice. And here is the answers to the 509 guided practice.